Hello there and welcome to Lower 6 Maths A. This is the Applied Practice Paper F. Here on question 10, a force equals mass times acceleration question. So, a particle of mass 6 kilograms initially at rest is acted upon by a force R equals AI plus 10J on a bearing of 300. Calculate the exact value of A. Well, let's draw this out. And a bearing of 300 is going to give us a 60-degree angle going this way. So 60 degrees here. Now we know that the height of this triangle here is going to be 10. And we have a 30-degree angle here. And we need to work out this this A part down below. So using a right angled triangle here, I've got opposite and adjacent, so I've got tan of 30 equals opposite over adjacent, that's 10 over A. Now tan of 30, that's 1 over root 3 equals 10 over A. So therefore A is equal to 10 root 3. But seeing as it's acting left, then in fact it's actually going to equal minus 10 root 3. Okay. Part B is calculate the magnitude of R. Now we did that a little bit earlier in the paper. This is the magnitude R is effectively going to be the Pythagoras distance on this force arrow here. So it's going to be 10 root 3 all squared, add another 10 squared, and that's going to give us the square root of 400, so that's going to be 20 newtons. Okay, part C, work out the magnitude of acceleration of this particle. Okay, so here we're going to use F equals ma, so the reaction, the R force here was 20, and the magnitude of the reaction, so 20 equals the mass, which is 6, times by acceleration A. So just so that we don't get confused between A for part A and acceleration as the value A, we're going to get 10 over 3 meters per second squared. Now the reason that we're working out the actual acceleration here in terms of a straight line at a bearing of 300 is because it hasn't asked for the it's asked for the magnitude of the acceleration rather than it split up into its I and J form. Okay, so part D now is to find the time it takes for the particle to travel a distance of 640 meters. So a bit of suvat here. S equals 640 initially from rest, from that point there. Acceleration is 10 over 3, and we want to work out, find the time, so we want to work out the time. So in this case here, it's going to be S equals ut plus half at squared. U is 0, so we can neglect that bit. So in this case here, substituting the values in, 640 equals a half times by 10 over 3 times by t squared. And doing all the calculation on this, we're going to get t equals about 19.6 seconds. Of course it's t squared, so you're going to get a plus or a minus, but we're just going to assume here that t is a positive value. Okay, so 9 marks for that.